Lesson 7.1, Pythagorean Theorem. We're beginning a new unit that deals with right triangles. If you're given two of the three sides of a right triangle, you can always find the third side by using this formula, Pythagorean Theorem. So we have this formula, a squared plus b squared equals c squared, where in this right triangle, the two legs are called A and B. Those are the two shorter sides that meet at the 90-degree angle. And then the longest side, C, is called the hypotenuse. The hypotenuse is always across from the 90-degree angle. It does not touch the 90-degree angle. So once again, as stated before, the hypotenuse is the longest side. We label it C. It's opposite of the 90-degree angle. And the legs are the two shorter sides. We label them A and B. It doesn't matter which one is labeled as A or B, as long as they're the two shorter sides that meet at the 90-degree angle. Also, we will further discuss where we get the Pythagorean theorem tomorrow in our next lesson, but for today, we're just going to practice with it. For our examples, we're going to find the length of the missing side to the nearest hundredth. Notice in this first problem, part A, that we have two legs labeled 4 and 5 units, and then a missing side, C, which is the hypotenuse. So we'll always start with the Pythagorean theorem, plug in the two legs, 4 and 5 for A and B, and it doesn't matter if 4 is A or B as long as 5 is the other one. Notice that C is our unknown side, so we just wrote our variable C. And we'll start by simplifying. We found the squares of 4 and 5. Then we add those squares. 16 plus 25 is 41. Now we want to isolate C, so we need to undo this square for C. Remember previously that we can undo an operation by doing its opposite. So the opposite of a square is a square root. So we'll square root both sides. When we square root C squared, we get C. And on the left side, when we took the square root of 41, your calculator would give you a decimal value that does not end or repeat. So we're just rounding to the nearest hundredth. We get 6.40, and I'm using the little squiggly looking equal sign because that just means it's about 6.40. So it is about 6.40 units. Part B, we have this right triangle, and we're given two legs, 11 and 16, and once again we're looking for the missing side C, which is the hypotenuse. We begin with our Pythagorean theorem, a squared plus b squared equals c squared, and then we'll just start plugging in what we know. The legs A and B are 11 and 16, and it does not matter which is A or which one is B. Then we will simplify the left side. So we found what each square was on the left side and then added them to get 377 equals c squared. And then last we will find the square root of each side. And we get that C is about 19.42 units, and we're finished. Part C, we have another right triangle. This time we're given one leg is 3, and the hypotenuse is 5, and we're missing the value for one of the legs, B. So we start this the same as we've done with the other problems. We plug in what we know. Notice that we don't know B, so we have a different configuration on the Pythagorean theorem, but we're still going to simplify and solve for the missing variable. So we have simplified. Now at this point, we want to think for a moment. Our goal is to solve for B. So I've got this term, b squared, that I want to get by itself or isolate on the left side of my equation. So I want to get rid of this 9. It's a positive 9. So remember, we can get rid of this positive 9 by subtracting 9 from both sides of the equation. And after that one different step, we end up with b squared equals 16. And at this point, we're now just trying to get b by itself. So we're going to undo the square by taking the square root of both sides. And so when we take the square root of b squared, we get b, and the square root of 16 was 4, so we've now solved that the missing leg b is 4.